Now, what would be the best way to simplify these three equations and three unknowns? Well, all right. I start out noticing that this is in terms of I2 and I3, but there's an I1 in both of these equations. So I want to eliminate an I1. So let's get rid of I1. If I can easily turn this into, I can subtract I2 to the other side and turn this into I1 is equal to I3 minus I2. Right? And then I can just put that in here. And I've eliminated I1, and I can use these two equations then to solve for I3. So let's do that. Here we go. I am going to take this, so that means that I3 minus I2 plus I3 equals 1. Right? Okay, cool. That means that 2I3 minus I2 equals 1. Right? All right. Now, the glorious thing about this is I could solve for I2 here and eliminate it in this equation. So let's do that. So I have that I can solve for I2 here and say that I2 is equal to 2I3 minus 1. Right? I'm bringing this over here and this over there. So I2 is equal to 2I3 minus 1. All right. But now I can very beautifully put this into here, right? Make that very simple. So I am going to take this, right? And I'm going to put this value in for the I2 over here. So I get 2 times 2I3 minus 1 plus I3 equals negative 1. And I can nicely erase this. Let's get rid of that. Okay. Distribute this 2 to here and here. So I get 4I3 minus 2 plus I3 equals negative 1. Right? So now if I add these up together, I get 5I3 minus 2 equals negative 1. Right? And I add this over to this side, and that becomes 1. So 5I3 equals 1. And so now we have one of our currents. I3 must equal 1/5 or 0.2 amps. Okay. Do you see that? You see how we did that? So now we already have 1 down, right? And from that, I can easily calculate I1. Okay. So if I1 plus I3 equals 1, right, then that means that I1 plus 0.2 equals 1, right? So if I subtract this to the other side, that means that I1 must equal 0.8 amps. Okay, now we have I1 and I2. We could use this last equation to solve for them. So we have our I1 is equal to 0.8 amps. Okay, so close. Can you feel it? Can you feel how close we are? Are you turning off your math phobia right now? I hope so. All right, so we have, that means I1 is 0.8, I3 is 0.2 minus I2, right? I'm going to take that amp out. I'm going to subtract this to the other side. So this is 0.6 equals negative I2, right? Now, that negative sign would get divided by negative 1 on both sides. We get negative 0.6 equals I2. What does that negative 0.6 mean again? All right, it simply means that I picked the wrong direction for I2, that it was really this way the whole time. Okay? And that's it. We now know the current through each of these different segments of the circuit and through every resistor simply by using a little bit of algebra. Okay? Again, Go through it again. Take your time. Go slowly. I will admit, this is the mathematically heaviest stuff that we're going to learn in all 2 semesters of physics. And there's something kind of comforting about knowing this is the peak. It doesn't get worse than this. All right? Okay. Now, as far as Kirchhoff's laws problems go, there is 1 million in your book and 1 million online. Plenty to practice. And I totally recommend you practice. All right?